You want 2 hours?
Yeah.
You want 2 hours? Professor Jana, you want 2 hours?
2 hours? No.
Sir, now you can share your screen also.
I am habituated in delivering lectures for 1 hour or 1.5 hours, but now time is only 20 minutes.
That I know. You will not be able to stop.
Ruksana ma'am, now streaming on YouTube, so you can start now. Okay. And also, Professor Jana sir, you can share your screen also.
And where is Professor Satpathy? Professor Satpathy?
Yes, sir, I am here.
Where?
I am here. I think.
I'm not. Not being.
Is it visible?
Yes, sir, it's visible.
Yes, sir, you are visible.
Yes.
So sometimes it creates problem when I go for full screen, but I am trying.
I'm starting.
Yeah,
yes,
sure.
please start.
Please.
Okay.
So if the screens, slide is not visible, then you just knock me.
Okay, sir, sure.
Okay. So time is very limited. In brief, I would like to share my deliberations before the August gathering.
Excuse me, sir, before starting our session.
NC sir.
Yeah.
Let the host speak something about the session. Okay.
Yes.
I will speak 1 minute only. I will brief the session. Then you will start, sir.
Okay.
A very good morning to respected chairperson, eminent speaker, participant, and esteemed organizers. I honored to receive the opportunity from organizing committee, especially Dr. Convener Dr. Azanarul Islam, founder Dr. Arun Kumar Singh for inviting me to chair this, to coordinate the session on the occasions of this 2-day international webinar on a very fascinating titles, River and Changing Riverine Ecosystem. So without wasting of the time, I will brief to this session. We have two guest speaker. We have two very esteemed and renowned guest speaker, Professor N.C. Jana, Department of Geography, University of Burban, Professor Shubhamita Chaudhary, Department of Geography, West Bengal State University. And 6 leading speakers will present and deliver their valuable research work with a given 20 minutes of time by giving the organizing committee. I'm very pleased to introduce our renowned, gracious personality, the Honorable Chairperson, Professor Ellen Satpathy, Director of UGC and Professor of the Department of Geography, University of Calcutta, a very dynamic, energetic, actively engaged in many academic assignment, research, published a lot of research papers, articles, books, and completed the projects and visited the many countries, academic purpose, and supervised many scholar project completed, and postdoc scholars also done PhD under supervision him. So we are very much grateful and thankful to the chairperson to giving the time to us to chair this session. Now I have a humble request to Professor Ellen Satpathy, chairperson, to opening the session with your few gracious words. Please, sir, just open the session with your few words, sir. Thank you.
Yes, the session is open, and without wasting time, I would like to invite first the Professor N.C. Jana. And I would like to request all the speakers, including the esteemed guest speakers and all others, to stick to the time schedule, because we have to finish by 1 p.m. today. And I know that for many of you, the time is definitely a constraint, but you are seasoned speakers, so you can manage it. Regarding the question answer, I think it can be taken up at the end of this session, and all the participants are requested to put their questions in the chat box. So thank you very much, and I would like to invite Professor Jana first. Professor Jana.
Thank you, Professor Ellen Satpathy, Honorable Chairperson of this session, Dr. Arun Singh sir, Professor Jagannathan, and Dr. Ajnarul Islam, Dr. Rukhsana, I mean the organizers. I am grateful that they have invited me to deliver lecture in this Foundation of Practicing Geographer conference. So my topic of deliberation is human intervention, geomorphic impact, and sustainable river health with special reference to flood in South Bengal. Basically, this presentation is to explore the impact of human intervention on the channel morphology and ecological health of alluvial rivers in southern part of West Bengal, India, with special reference to flood, and find out appropriate management measures to recover and restore biodiversity in general and river health in particular. Basically, we cannot control the flood, you know. For the time being, we can manage so that human casualties and the property damage can be prevented as much as possible. So basically, I will focus on the lower reaches of Damodar, Mundeshwari, and Darakeshwar. So without wasting much time, directly I am going to my slides, and each and every slides I cannot explain because of the time constraint. So there is a famous statement of Gurudev Rabindranath Tagore that, let me say in a whisper behind the backs of the irate engineers that the natural drainage of the country has been tampered with and the country is taking its revenge. So what we are thinking today, Gurudev has apprehended that much before, that how we are intervening in the riverine phase and the river is taking its revenge.
944. Okay.
So for centuries, humans have been enjoying the natural benefits. We are enjoying natural benefits by the river without thinking its ecology and health. So our philosophy, our thinking was confined to merely prevent the flood by structural measures, and during flood or after the occurrences of flood, it was confined to the mere relief distribution only, but never we thought on the ecology and health of the river. And human activities has gradually being increased, and that sometimes induce channel change more significantly than those by natural events. And man has changed the nature of many of the world rivers. Basically, we are living in a tropical country, and the South Asian countries, the tropical humid region and tropical humid rivers, they are basically the controlled river system, controlled by the government initiatives and controlled by the human intervention. So these are the outline of my deliberation to identify the areas of human intervention into the alluvial river system in humid tropics, to investigate the geomorphic impact of human intervention on alluvial river system and find out appropriate management measures or processes to recover and restore biodiversity in general and river health in particular, to provide lessons for the people. So, who can use the river in a sustainable way? We have to give lessons to the people. People should be aware, and we have much to play in this regard, because we are the intellectuals, we are the geographers, we are the environmental experts. We have to increase the awareness so that people can take the lessons from the events which are happening today. So identified areas of human intervention. So human modification, particularly construction of dams, embankment and sand mining, and climate change, that may have some effects of channel morphology, fluvial processes, hydrological and biological characteristics of a river, as well as socio-economic life of human activity. So human intervention on a river that can be identified in terms of damage, dams and barrage construction, long artificial embankment, huge amount of extraction of sand, which is very much we have observed in the lower reaches of Damodar, Mundeshwari and Dharakeshwar, and river encroachment. Definitely, this is one of the most important points to be considered, how we are encroaching the river, the alluvial plain. So now dam construction. So initially when, Damodar is a sorrow, it is recognized as the sorrow river. So government thought that if we construct the dam, then the lower reaches of Damodar, or so as to say some parts of the lower Bengal basin, the flood can be prevented. So initially it was successful. But with the passage of time, now the dam or the reservoir in the upper reaches, they are now posing problems to the, the people for the lower reaches of Damodar basin, Mundeshwari, Dharakeshwar, Rupnarayan or whatever. So before the construction of DVC dams, the flood peaks were high, but the duration was small. The construction of dams has moderated the peaks, but increased the duration of floods. It is as per the Mansingh Committee, 1959. And human modification, construction of dams and siltation within it. After the construction of the dam, it was constructed during the tenure of Pandit Jawaharlal Nehru. So there has been constant siltation within the reservoir. The depth of the reservoir has been reduced, and the carrying capacity or the storing capacity of the reservoir with the passage of time has been reduced. So see Durgapur barrage. With the passage of time in the lower reaches, how the number of bars are increasing. Because due to the construction of Durgapur barrage, the natural flow of the river, Damodar river, has been prevented. And hence the increase in the number of bars in the lower reaches of Damodar. So changes in the riverbed profile. Because I have already pointed out that Damodar is a controlled river system, and not merely Damodar, but the rivers in the lower Bengal basin, they are the controlled river system. So with the construction of barrage, with the construction of dams in the upper reaches, there has been changes in the riverbed profile also. Embankment. So embankment was considered as the flood control measures. This is one of the important structural control measures. But the construction of embankment should be adopted in case of utmost necessity. Now it has been proved failure that construction of embankment which increases the stream power and increases the probability of flood of any river, particularly in the lower Bengal basin. To measure initially offered protection against low intensity flood, but the long-term effect of embankment is decay of river. The construction of embankment, the construction of reservoirs, the construction of dams, all these measures are significantly contributing to the decaying of rivers. Now, Damodar is considered, it is in the decaying stage, which are to be revived, keeping in view the river's ecological health in particular and biodiversity in general. So consequences of embankment. See, construction of flood embankment as flood control measure would be like mortgaging the future generation to derive some temporary benefit of the present. I have already pointed out, if you construct riverbank, it will give you the temporary benefit, short-term solution. But It is required in case of utmost necessity, but for a particular segment, not for the entire segments of the lower reach of any river, because ultimately it will contribute nothing but the breaching of embankment because of the increase of the stream power. So see, river cross section without embankments, it is reducing the risk. Population either have temporary settlement near the floodplain or choose the settle away from the floodplain. Without embankment, water spread over a larger area during flood. So if you confine the river flow by the construction of embankment, definitely that would have an adverse effect in the long run. River cross section with embankments. Population settle close to the embankment, assuming they are safe. But sediment rapidly builds up within the confines of the embankment, rising riverbed, as well as water level within the embankments, always the level of surrounding. Water logging due to rainfall, and that will breach the embankment, definitely. That has been observed in case of Ajay. So aggregation of riverbed within embankment. So construction of embankment on the left bank of Damodar River bring adverse impact on the riparian environment by hampering the natural evolution of the floodplain. As a result, the sediment in the river slowly gets deposited within embankment and raising the bed level. And as the bed level rises, there is strong probability of the spillover of channels, and the adjoining area of the lower reaches of Damodar gets inundated. So bank revetment does not bank revetment does not ensure protection. So it is one of the important measures, but it does not ensure the protection of the embankment with the help of boulders or whatever, but it does not ensure protection in the long run. So sand bund, it is one of the most important points to be considered, how we are intervening into the flowing river. See, this is one of the snapshot in the river Mundeshwari. So I have visited that place, that there has been a construction of sandbar across the river valley, because the upper part, I mean in the left side, they are storing water for the practice of high-yielding variety paddy during post-monsoon season. But what will happen to the lower portion, I mean in the right side, lower reaches? Sand band, locally known as Boro band, across Mundeshwari River for the storage of river, for irrigating the adjoining land towards HYV paddy production and potato cultivation during post-monsoon season. This sand band is constructed by the Irrigation Department with the assistance of local people. Despite its importance in post-monsoon crop production, this artificial band hinders the natural flow of the river and significantly affects the channel dynamics, which are responsible for inducing flood in the surrounding area. So one way people gets benefit for the practice of high-yielding variety paddy, but on the other way, it is rigorously changing the river dynamics and induces the probability of flood in the lower reaches. So these are some of the areas where we are gradually intervening in the riverine phase. So we are talking to the person of the Irrigation Department. So he has, he has some sort of logic. See, official of Irrigation Department explaining the mechanism and importance of Boro band, as well as its estimated cost. in response to a question on its worst impact on channel morphology, he said that the temporary boro band is destroyed before the onset of monsoon rain, which seems inconsistent with his statement. But somehow he is explaining the situation. The temporary sand band or the boro band, it is not destroyed during monsoon season. But he is claiming that the sand band is destroyed before the onset of monsoon. Sand mining. Consequences of sand mining. Consequences of sand mining on river morphology. So these are the selected segments for study Sillaghat to Sadarghat in Damodar. How there are many types of sand mining process. I mean, one is bar skimming, scraping the top layer. Another is dry pit mining, mining from dry ephemeral stream beds. The third one is wet pit mining, extraction below the water level or within the perennial stream. So what are the identified consequences due to sand mining? Shifting of Thaloc and instability of river bars, channel platform changes, shifting of pool refill sequence and riverbank erosion, variation in channel width, riverbed degradation. So this is segment-wise changes of platform in different years. I am not explaining because due to time constraint. So changes in the cross-sectional profile of river Damodar segment. Formation of undulating riverbed due to extraction of sand. So how the extraction of sand by the unscrupulous sand mafia, we used to call them sand mafia because there are certain rules and regulations imposed by the government of West Bengal, but who cares? These are all on paper. Now government is strictly imposing the rules framed by the Irrigation Department to prevent the irrational extraction of sand from the lower reaches of Damodar. Migration of Thaloc near Sillaghat due to capture of former mining pits. See how the Thaloc part is shifting. So the left side, what we can observe that this is the former Thaloc in 2012 and the present Thaloc, I mean, it has been started in 2013. How the Thaloc point is getting changed with the passage of time. This definitely has a worst effect on the channel morphology. So how the sequence of pool ripples in a channel are getting changed. I mean, it is crystal clear from the figure that sequence, I mean, the pool ripples, the sequence of pool ripples in a channel are getting changed with the passage of time due to the irrational extraction of sand from the channel bed of lower reaches of the Damodar. Sand mining as the cause of riverbank erosion. So this has been clearly identified. The mining pits have been clearly identified near Idilpur and Jujuti. And the riverbank erosion. I mean, these are the snapshots of riverbank erosion. I mean, in different places of lower reaches of Damodar. And encroachment. See, river encroachment is considered to be the most important point because we are living in a country where population is yet to reach 140 crores. So there is a dearth of space where to practice the agriculture, where the people will settle. And if you visit the lower reaches of Damodar and Ajoy, you will find so many chores have been encroached by the downtrodden or the poor people. So they are compelled to encroach the place because they don't have much financial capability to purchase a piece of land where to settle. So definitely they have encroached the natural bars, and this encroaching the natural bars which are posing severe problems to the channel geomorphology.
Sir, sorry,
Hello?
sir, interrupt you. Please try to conclude.
Yeah, sure.
Okay.
So see, this is one of the snapshot of the paleo channel here. I am in the concluding part, only I will take 1 to 2 minutes. So this is another snapshot, how agriculture is getting practiced within the river valley. I mean, paddy and potato, they are cultivated within the convex side of the Kanadarakeshwar. It is a snapshot of the Kanadarakeshwar, which has been encroached for agricultural practices. So these are small thing, but we have to think how to prevent the encroachment. So this is another snapshot of encroachment. It is near Madokhana Hugli, where Darakeshwar and Mundeshwari get mixed, and a new name, Rupnarayan River, has emerged. It is a tri-junction point of Mundeshwari, Darakeshwar and Rupnarayan, Howrah, Hugli and Midnapur. I mean, Paschim Midnapur. Encroachment of riverbed by the construction of commercial building at the confluence point of Darakeshwar, Mundeshwari in Madokhana, Hugli. Fluvial response. I mean, all these images or snapshots, you say, these are self-explanatory. This is the snapshot of Damdam Airport. I mean, this is the snapshots of 2015 flood. This is the Sialda railway station. This is the Belud Mott, Howrah. This is the Kankalitala, Bolpur, Birbhum district. This is the Desra village, Kotulpur, Bankura. This is Ramchandrapur, Khanakul 2. This is Ghuskara, Badwan district, and this is Mayapur, Nadia. This is Chapadanga, Hugli. This is Nutongram, Durgapur, Badwan district. I mean, that time it was Badwan district. I mean, undivided Badwan. This is Rambati. Rambati near Birbhum. I mean, this is President's home. I mean, former President Pranab Mukherjee's residence. Raina, Badwan district. So, I would like to conclude. I mean, we have to emphasize on the process-based understanding. It is time to develop a process-based understanding of rivers and identify all attributes of the Earth's surface, which are involved as changing agent of river morphology for better river management to shape the river and its environment. Time has come to realize that a long-term solution of floods or river management does not lie in controlling the river, but managing it through integrated planning and understanding the riverine processes. So in this direction, the most important measure is appropriate land use zoning. This is a model which have been introduced by Australia flood management best practices, principles and guidelines. So Indian rivers are characterized by narrow channels confined within the wide valleys. And continuously increasing pressure of population growth on land has led to the intensification of settlement even within the floodplain and wide valley of the rivers. I have already pointed out how the chores, all the chores are not stable, unstable, but all the chores have been encroached by the downtrodden or the poor people. Here the figure, it is clear that we have to divide or classify the river valley into different as per the intensity of hazard. Where low hazard is there, you can go for range of land use practices. Where extreme hazard is there, this part should be left. So there has been a paradigm shift from flood control to flood management. And I mean, the river experts or the environmental experts, they know that we have to live with flood. I mean, we cannot do nothing, but we have to live with flood. We have to introduce the coping strategy. How the building has been constructed. I mean, this is a snapshot of Khanakul. So they have the experience that building should be constructed by putting the pillars. So by these measures, people can reduce the magnitude of damage during the occurrence of flood by changing and cropping practices, construction of residential building about 15 feet from the ground. So if you visit the Khanakul or Goghat area, the school buildings have been constructed much above the ground surface. So river management does not lie in controlling the river, but managing it through integrated planning and understanding the riverine process. So thank you for your patient hearing. I cannot explain all the slides because due to time constraint, you know. Thank you.
Thank you, Professor Jana. We have already overshooted by 13 minutes.
Okay.
So without wasting time, I would like to invite Professor Shubhamita Chaudhary. Madam, please. They have any query, they can put the question in the chat box, and our esteemed speakers will definitely respond to those queries at the end of the session. Madam Shubhamita Chaudhary, are you here?
Yes, I am there. Loki, can you hear me?
Okay, please. Yes, please.
Okay.
You start. And we have to stick to 20 minutes. Okay. And if it is less than that, definitely it will be highly appreciated. Thank you very much.
Yes, don't worry. I won't take much time because I have very little to say, unlike Professor Jana, who had so much to tell. I have a very brief presentation based on my field experience. So this topic that I have chosen to present today, it is an interdisciplinary topic. It has something to do with geomorphology, and there is also a part on behavioral ecology of some mudflat fauna, which we found along the mudflat in Gangasagar area. So I'm going into my presentation directly. There is something coming here. Please move this window away from the presentation. How to move that? There is something coming on my screen. Please move this window away from the shared application. I can't.
No, I think, ma'am, I think multiple windows open in your desktop. Please close.
Oh, okay. Okay, I think now it will be okay.
Yes, good.
Yes. So the study area, which is located in the southern part of Sagar Island, this is the Gangasagar Creek, and we chose some around 2,600 meters, like 2.6 kilometers or so length of this channel until a log gate, which is at Lokhi Bazar area. And that was the point which we chose because that was the limit till which the tidal inundation was possible. Upstream of this log gate, the water was totally controlled by the shutting down the lock gate. So there was not much of tidal activity from the southern side. We chose 3 stations. Station A was the innermost, B in the middle, and C near the mouth of the creek. So our objective was to understand the nature of the tidal behavior of this inlet, and if we can at least roughly estimate the sediment budget, that is the amount of sediment that is being deposited in the creek itself. And then we wanted to see what is the relation between the geomorphic character of the inlet, their the slope of the banks, and how much area along the bank is inundated during the tide, and what is the rate of sediment deposition in the mud flat. Now, based on these criteria, we started observing the floral and the faunal distribution. I am only going to stress on the faunal activities in this paper. The floral activities, that is mainly the mangroves, that is quite well documented by several geomorphologists, especially Professor Ashish Kumar Pal. He was there. I don't know if he's here today, but he has very meticulously documented the floral distribution. So I'm only dealing with 3 major species which are present along the Gangasagar Creek. I will go into that in my next slides. Now, as far as the methodology is concerned, there was tidal monitoring, which was carried out for more than 10 hours. Then there was, preparing on a grid-like frames along the bank of the, mud flats, a 1 square meter grid from the creek towards the top. And then we took cross sections by theodolite and dumpy. And then there was very, very intense observation for almost the entire day. Every 30 minutes, we used to take observations of the activity of the faunal species. So when we did the tide monitoring, we later on plotted the hydraulic gradient, which we found along the creek. And this is the station C, as I showed you. This is at the mouth of the inlet. And this is the middle one, and this is upstream. So we started our survey from there. That is why the 0 distance is at the upstream location. Now, very interesting pattern we can see here of the tidal rise and fall. The water levels were measured at 3 stations at the same time, at the same, we matched our watches, and then we took measurements at 3 different locations. And then we adjusted all the heights to the chart datum. Now, if you see this hydraulic gradient during the incoming tide, which is shown by the red, the red lines. So at the mouth, the tide was rising very fast. We did our survey from low tide to high tide to again low tide. So the tide was rising very fast at the mouth. We started around 6:40 or so, but then there was hardly any movement of water. Thus, water started moving from 8 o'clock or so. And so every half an hour, I have marked the water levels, though we took readings for every 10 minutes, but we are representing here every half-hourly increase in the tidal level. So you can see that at the mouth, the water rose very fast. From 8:30 to 9:30, the rise was very, very fast. But if you see the rise in the farthest station, then there was hardly any rise between 8 and 8:30. There was hardly any rise from 8 to 8:30, and then the water started rising. You can see that there is a very steep gradient from the C towards B station, and this gradient from B to C is rather gentle. But when the water was receding, then again we found that the gradient from B to C was very steep during the fag end of the tidal period. But the withdrawal of the water during the last phase of the tide in the C station was very, very slow. So what happened is, if you see the tidal curves, then the curve at the mouth, that shows the maximum range. As you go inside, the tidal range is also less. And another very significant pattern is there, that in almost all the cases, the water was rising faster and it was falling down slower. So it means that there will be a substantial amount of deposition inside the creek. And that is how the tidal banks were developing along this creek. So along all these three cross sections that we took, we calculated the discharge at each location, and then we tried to find out the tidal prism, that is the amount of water that is entering during the tidal period. If you can see these two images, during low tide, this is the image of station C, the innermost one. There is hardly any water in this creek, but this is during high tide when there is a lot of water. This is station B and this is at the mouth. So what we tried to do is, we collected water samples for all the tidal periods, and the amount of suspended sediment concentration was found to be lower when the water was going out. But the incoming, the amount was much higher. So what we tried to do in this small calculation that we did, we found out the tidal prism, that is the total volume of water that is entering the creek at the different stations. And then we found out the incoming suspended sediment concentration, the average, and then the outgoing suspended sediment concentration. When we subtracted, we saw that there is a balance of material which is getting deposited inside the creek, and the balance was highest at the mouth, where we saw a big ebb tidal delta forming, and the amount was lesser at the the end point of the creek. Now these are the dominant species that we considered for this study. The dominant species were the large telescopium, the small telescopium. These are very, very small, about 1 centimeter or so in their length. The large telescopiums is around 3 to 4 centimeters in their length. This is mudskipper, a very, very common faunal species at the mud banks. And then we have various types of fiddler crabs. So fiddler crabs, they have one claw which is very big and another is very, very small. But these are the male species. In the female species, the claw types are not much of difference. So these main three species, the crabs, the telescopium, and the mudskipper, this we took into account when we are studying the mudflat behavioral response. So we took some physical parameters, that is the topography or the geomorphic character of the inlet, the slope of the bank, etc., and the tidal level, and then the period of desiccation. So the period of desiccation is actually related with the sunshine. So we also noted when there was sunrise, and then how many hours of sunshine did that area get, when there was cloudy or when it was sunny. So all these things were noted down. And the ecological indicators, we noted when the species are stationary, they are not moving at all. And then they start moving towards the water. There are some movements which are away from the water. Then these are all locomotion of the faunal species. And then we found there are two very important functions. One is feeding and pelletization. That is, they take out the algal matter which contains their food from the soil itself, that is the mud itself, and then they form very small minute mud particles which they spread on the mud flat. And then grazing, that is, they look for food, they graze the entire area. During this, they fight with each other also. And then there is another very important movement, that is moving inside the water, that is swimming inside the water. So, and hypothetically, we can see the ecological setup of this entire mud bank. So here you have the mangrove plantations. These are all planted mangroves. There are some natural mangroves, but mostly there are planted mangroves. And then you have the spring tidal level up to which the highest high tide reaches. Then you have a portion where there is no vegetation. There are rill marks which are formed by the seepage of the water, retreating water when there is low tide condition. Then the major portion of the mud bank has saline grasses, and then there is a portion which is above the spring high tide level. This is spring low tide level, and above the spring high tide level, there we have some mangrove associates like Acanthus ilicifolius, and then Sesuvium, Portulacastrum, that type of species we find here. And beyond that, there is this zone of sandy area where we find the Casuarina plantations. Now, when we saw the the colonization of, or the concentration of the species along the bank, we found there is a difference in their zonation depending on the tidal rise and fall. So we have marked the levels of the tide along the surveyed cross section, and then we have marked the zone of the mud skippers, then small telescopium, then large telescopium, and then the crabs. So what we can see is that the lowest portion of the mud banks, they are occupied by mud skippers during all tidal conditions. And the small telescopiums, they are restricted within 3 meters from the low tide line. So the small telescopiums, the large telescopiums, and the mud skippers, they are all at the lower part of the mud bank, that is within 3 meters from the low tide line. Above that, we find the crab species. So we divided this entire zone into 4. This is the A1 zone. This is a very small, tidal inlet which had no water when the in low tide condition. So we took this as a sample area and we tried to find out the microzonations of the crabs. So this part is A1, and this is the zone which is dominated by the mud skipper. Then in the zone A2, here, this is a little above the lowest level, and this is dominated by the large and the medium-sized telescopium, and also by some brown-colored crabs. Then above that, zone 3, these crabs are very small. These are not like the beach red crabs that we see. These crabs are at the most around 1 centimeter, at the longer axis of their crust. So they are very, very small. So then the A3 higher up, here you have the saline grasses. There you find the small red crabs. This is less moist area than A2. And then we go further up. Here we find some yellow small crabs. You can see that there are two. This is the male, this is the female. The male has one big claw, but the female has no, all the claws are of the same size. So here the material is a bit sandy, unlike the lower levels, and there we find these crabs. Now we start our observation. And this observation again, this thing is coming. What to do? I closed all windows actually. Is this blocking your view? It's blocking my view.
Our view also.
Okay, I don't know why it is coming, because I closed all windows actually. Can I check again for?
Yes, ma'am, you can continue, ma'am.
I don't have anything else open.
Now it's all right.
Yes. Okay. So this is the result of our observation, the ecological observation. And here you can see that in the upper axis, I have given rising tide, the peak of the high tide, and then the falling tide. And these are the activity categories that I mentioned briefly: moving towards the water, moving out of water, feeding and pelletization, grazing, and moving inside the water, that is swimming. So what you can see is the blue are the large, green is small telescopium, mud skippers are the orange, and the blue is the crab. So what we saw in our initial period of observation, that there was actually no movement of the large and the small telescopium during the rising tide. They just look like dead shells. But when the peak of the tide started receding and there was falling tide, then the telescopiums started moving. And we understood that this movement of the telescopium or the other species, especially the crabs, you can see that the crabs are moving only after the highest high tide is over. That is, the peak has receded. So we, understood that the movement of the telescopiums and the movement of the crabs, this was mainly controlled by one, the type of sediment, that is mud or sand, and secondly, it is the nutrient availability which is giving them the food. So the tidal water is carrying the algal material which is their food, and when it is receding, then the algal material is spread over the banks and mixed with the mud, and that is grazed by the crabs and the telescopiums both to have their food for their sustenance. The mud skippers, they are actually different in their behavior. They had no activity when actually we didn't see them at all when there was, in the initial part of the tide. But then they started appearing when the tide has attained quite a substantial level, and then the mud banks were all wet and slippery. So then they started coming out and they were moving everywhere. So you can see that the dominant movement of the mud skippers are all during the, the high tide period. But in the low tide period, the mud skippers actually disappeared. So this is the time, if you can see the hours. So this is the time when there was noon period. After the noon, we had afternoon period. It was very hot and the mud started, drying up. When the water was receding, the sun was very hot. So the mud started desiccating, cracks started appearing, and the mud skippers just disappeared. So we found that actually there is a relation between desiccation period and the movement of the mud skippers rather than the nutrient availability and the tidal level. So different species, the mud skippers are sensitive to sunlight, the telescopiums and the crabs, they are sensitive to the tidal level. Yes, I'm just concluding, 2 minutes more.
Okay. Fine.
So if you see these correlations, you can see that there is a weak negative correlation. These are the 4 grids, A1, A2, A3, A4. And A1 is towards the water and A4 is towards the land. So there is a negative correlation in A1 and A4 grid between, water level and the burrow diameter. So when we move away from the water level, we find bigger burrows of the crabs. And some of the relationships are positive, like water level height and the burrow diameter in A3 grid. So that is the grid which is at a higher level. And in the A4 grid, we find that there is a very weak negative relation. Now that is because, in A4, as I showed you, there is grass and there is less of water inundation. So the amount of nutrient availability is also decreasing. So this is the last finding that I would share with you. Here, this is the A1, A2, A3, and A4 grids, and we found out the orientation of the burrows along the bank of the Gangasagar Creek. And what we found is that towards the water, all the burrows are oriented towards, the lower slope, the burrows are oriented towards the water. That is, they are actually, in need of the algal matter, which will come floating with the water. But as we go higher up in this grass zone, A4 zone, you can see that the burrows are oriented away from the water. So here there are more options. It is not only related with the nutrient dynamics. I think I'm done with this. I already actually discussed the movement of telescopium. This is sensitive to desiccation and the are sensitive to desiccation. The crabs, on the other hand, are more active during the falling tide when they are going for their nutrient. Okay, thank you.
Thank you, madam. Next, Shashanko Gayan, are you here? Professor Shashanko Gayan.
Sir, 1 second. 1 minute, sir.
Actually, Madam Subhamita's paper is a very interesting and based on field-based research work, and it is tempting to ask a question from me that your work is definitely a new one and based on the habitat of those creatures, mainly those are the marine creatures. But is there any predator-prey relationships, particularly from the land side? Some of the animals, they may feed on these creatures. So is there any abundance, particularly during the nocturnal time or any other time?
It's a good question, Loki. Actually, nocturnal behavior we were not able to monitor. But among these species that I discussed, there is no prey-predator relationship. But the mudskippers, they sometimes, they eat some very small insects which float in the water, but not among these species. And these are so small. These crabs are so small. They are also not harvested for human consumption also. Only the mudskippers that are sometimes, we are the predators actually. We fish out the mudskippers, we eat them, we cook them and eat them. But in this small habitat, there is not much of prey-predator relationship. Because
thank you very much, and thank you very much, madam. And there is a lot of scopes for future research by the young generation. Thank you once again, and let us move on to Shashanko Gayan. Professor Shashanko Gayan, are you here?
Sir, 1 minute, sir. Sir,
yes.
I will say something for our eminent guest speaker. I would like to introduce.
Okay, please, yes, madam.
Sir, it was okay. So it was our great pleasure to listen our eminent guest speaker, Professor N.C. Jana, and he is a professor from the Department of Geography, University of Burdwan, and Professor Shubhamita Chaudhary. She is a head and professor, Department of Geography, West Bengal State University. We are very much grateful and thankful to our esteemed both of the guest speakers for their knowledge and enlightening to us with their well-structured and detailed presentation to cover the most of the aspects to save the health of the river and its sustainability. Both of the scholars, both of the geomorphologists definitely actively engaged in many research works, delivering the lecture, chairing the sessions in the pandemic situations also, and collaborating research and enlightening to all the scholars to all over the corners of India. So we are very much thankful and grateful both of Professor Shubhamita Chaudhary, Professor N.C. Jana, to giving the time you are valuable and to present your valuable research and presentations in this platform. Thank you, both of you. Now next speakers, I would like call Dr. Paramita Chaudhary. She is a associate professor. She is Department of Geography, Qazi Nazrul University. She will speak on the management of river basin water resource, a participatory approach. So Paramita Rai Chaudhary, she is present here, I think. Yes.
Paramita, we are running a little bit late, so
yes,
if you can manage within 15 minutes, I think it will be wonderful. Thank you very much.
Thank you. Very good morning to all the dignitaries present here. and I convey my regards to Professor Shotri, Session Chair, and also Dr. Sanara, and all the dignitaries and the distinguished audience over here. Since we were dealing with the river and the river dynamics, I will take you towards a different aspect of river, and it is basically I will speak on the management of the river basin water resources from the perspective of participatory approach. Now, sharing water resources have remained as one of the most contested issues in managing common property resources. Unlike other water resources, rather other inland water resources, dispute over river water sharing extends over several nation states, subnational regions, and often across different communities. Now, this conflict over the river basin water resource sharing generally intensifies by the existing socio-economic and the political setup, and also the administrative setup of the constituent regions. And it is always, we know that this kind of setup is always aligns towards a new equilibrium. Now, given this context, or given this situation, we would like to see that how participatory approach can give us a framework for analysis and a framework for solution to this conflicts. Now, participatory approach or participation approach has its origin in 1970s, basically as a part of post-colonial community development efforts. And during the last 50 years, participation has become one of the shibboleths in the contemporary development theory and practice. And also today, this is one of the very, very important approach or important perspective in analyzing and managing the common property resources. Now, when we try to see, or when we try to analyze exactly what we mean by participation, then we say that it is basically a dynamic group process in which all members of the group contribute towards the attainment of some kind of group objectives, share the benefits of the group activities, and exchange information and experience of common interest. Then they, by this design, follow the rules, regulations, and the decisions taken by the group. Therefore, participation refers to the involvement of the local population in creation, content, and conduct of a program and a policy that is designed to change their lives. Now, community participation may be taken, or is generally taken as an instrument for empowerment. Now, we all know that when we talk about development and following Paul and also following Cleaver and others, we have seen that, that when we talk about participation, the concept of empowerment is imbibed or inbuilt into it. Therefore, we try to say that participation, at one hand, gives us a scope to reach the objectives of the projects or the intended objectives of the projects, and it also gives a scope for empowerment of the people, particularly the weaker groups involved in this entire development process. Therefore, it provides scope for more equitable sharing of resources and also of an equitable share of power. Now, following this, we could take that take this argument further, and we see that, you know, even from 1980s, 1960s, 1970s to 1980s, when we come to the present day context, or even when we see the way World Bank tries to operationalize this concept, and also in the present day researches, it has been seen as a process where people take part in identification of the problem and also analyze and also find out the solution to these problems. Therefore, it is automatically associated to the collaboration, deliberation, involvement, social learning, and also an engagement and management of the issues. Now, if we come to the frameworks that has been given by the proponents of the participatory approaches, and I will start with the most classical framework that has been given by Einstein, which we all refer when we do take note of the participatory approach. It's by Einstein, Sherry Einstein, and according to Einstein, that it is being called as a ladder of participation, from where we see that a non-participation or a system of non-participation, where the technocratic or the bureaucratic approaches for a development generally is being taken. And there is initially a manipulation from this kind of a central level, or top-down approaches, and it's a kind of a manipulation and a kind of a therapeutic treatment of the problems. Now, from these kinds of a development framework, as we move towards the more participatory framework, and we go up by the rungs of the ladders, we see that from non-participation then involves a kind of a tokenism, where people are generally consulted, meetings are being called, and then their views are being taken. And then gradually it becomes, ultimately it becomes a citizen control. And it's a delegated power to this whole process. Now, when we are able to achieve these kinds of a participatory framework, I come to Fiome's analysis, where in present day, from say 1970s to, if we come to 2006, what we see that this ladder of participation, or this whole framework of participation, is actually involves a kind of a complex or a multiplicity of agents and factors. Now, at one end, we could see that, it is an ex parte of administration and a kind of an elected representative controlling the system, which is a kind of a more exclusive system. And from that framework, we move towards a kind of a situation where it's a kind of a diffused public sphere. That means it's people who actually are self-selected individuals. People offer their participation, and people take part in the decision-making process. Now, here also two other important aspects I would like to mention. One is definitely the budgeting, or the funding of the projects, and also the ideas of the benefits that is accrued to the person, individuals. So all this, according to Fiome, he gives a crossroads of all this, where from the budgetary perspective, from the central control or the central governmental perspective, from the local administration, all comes as crossroads and creates a kind of a complexity of situations. But even in this complexity, we can achieve participation, and according to Fiome, that participation, when it is achieved, it actually leads to a kind of a situation where we can see that it inherently promotes, number one, empowerment. As we have all already said, or I already discussed, that participatory approach promotes empowerment. So we take all arguments. I can take the name of the stalwarts of Robert Chambers, Einstein, Tocqueville. Everybody says that to promote participatory approach, the most important part is it imbibes or it delivers empowerment. Then definitely it is an efficient system where from different perspective and application of participation in different kind of resource management, not only river water management, other inland resource management, forest management, different kinds of basically common property resource management, also planning for land users, and planning, preparing a particular sustainable land use planning. In all these cases, involvement of the communities or involvement of the people, but directly kind of influenced or affected by these decisions, definitely creates a kind of an efficient project or efficient system. It is definitely effective and also equitable. So from a perspective, from a participatory approaches perspective, we undoubtedly can say that this is empowering, efficient, effective, and equitable approach. Now, as we come to the issues of river basin water resource management, I would just like to say that the approaches of river basin water resource management, or initially what we tried in this approaches, or the three most important strands of approaches in river basin water resources management is, one is definitely the ecosystem approach or the comprehensive river water assessment approach. Then the integrated or integrative approach of integrated water resource management, and definitely the one is the participatory approach. Now, if I contextualize participation in the crossroads of these three approaches, I would just like to say that in the global north, in sustainable development in the global north was mainly achieved by the practitioners and the development experts. While in the global south, where the environment is contested, not because it is valued for its amenities and aesthetics, but its exploitation creates economic value. Incorporation of the local knowledge of the local people, and particularly I would like to mention of the rural poor, is inevitable. So participatory approach gives this scope for involving the people into this kind of planning or river basin water resource management. Now, another very important part is from the Western cultures also, and also in the present context of democratic institutionalization, we talk about people-centered. We talk about people-centered principles. Now, this people-centered principles we promote in case of education, business, public policy, international relations, international reliefs, and also in case of development programs. So therefore, the largest, humanist movements in the natural and social sciences, the emergence of the postmodernist theories, and whole idea of, as I quote Robert Chambers, people past. If we have to stick to this paradigm, then definitely it is a participatory approach that we have to adhere for the management of the river basin resources. Now, what we exactly try to say, or what we exactly try to mean by this kind of approaches in case of sustainability of the management of river basin water resources. Now, as we have already said, that the river basin water resources, or the river basin per se, is a very, very conflicting area where different kinds of interests and different kind of conflicting objectives coexist. Now, even within a subnational region or within a nation, I mean, within different regions where different communities live, the upper riparian states, the lower riparian states, and all these kinds of conflicting situations coexist. This is definitely addressed when we take into consideration, or when we involve the communities who are affected. So the conflicting objectives and the conflicting interests, which is generally coexists, they are taken into consideration and they are given due importance, and the people generally reach to a decision which is applicable. So people try to resolve the conflicts before the policy decision is taken. So the policies that generally are taken by participatory approach, they bring about more effective actions. So what I was trying to say by this effectiveness of participation is that the decisions are generally better, or the generally accepted by the communities to be implemented. Now, the decision which is taken through the participatory approach are also satisfying the objectives, or satisfying the interest of the communities. Now, these communities therefore consider these decisions or these policies as a fair and a legitimate decision. Therefore, they are generally take these decisions as a very justified decisions, and they comply, they adhere to these kinds of decisions. So the whole decision-making process, it in itself creates an equitable conditions, or a situation which is more equitable, and therefore when the decisions are implemented, the conflicts on that part are generally less contested. Another very important aspect has been found of this participatory approach in case of sustainable river basin water management, that this requires a information intensive process, because in case of river water resources, it is basically a very information intensive process, where a variety of issues, a veracity of different types of issues comes into play. Therefore, when an objective decision is required to made, we all know that it involves a kind of situation where we need the rainfall data, maybe the availability of the water, the changing pattern of the rainfall, the availability of water due to anthropogenic interventions, then also the changes in the agricultural production system in the river basin areas, and eventually the use of waters, the kind of industrial production that takes place, the traditional river water resources use that exist in an area, then of course also the way our community participation, or the control over the river waters has been practiced in an area. So all these things are needs to be taken together. So at one part, it is the socio-political situation. At one hand, it is the ecological conditions. Another hand, it is the geohydrologic conditions. So all these things needs to be taken together into a very intensive network of knowledge. Now, this system, when we talk about participation, it actually brings the knowledge holders together. So when we take the knowledge holders together, and when we take them into one particular scenario or one particular platform, we generally are able to promote a better kind of a policy perspective. Now, participation therefore involves information supply, consultation, active involvement of the people, and it leads to a better quality of decision, effective decision, and also legitimacy, gives legitimacy to the decision that has been made. Now, I just would like to say that if we go by different examples, and I take here the examples that is given by Gamakar, Tates, Hutama, from different case studies, we see that in the St. Lawrence River water level operating system, there was a mechanism developed where, along with the technocratic approaches, the local people and their involvements were taken together. Then in case of urban river management in Birmingham, it was the poor ecological condition and environmental conditions of the river, where the communities, the users or the residents along the rivers, they formed.
I'm sorry to interrupt you, please. Time is over.
Yeah, I'm almost on the end of my discussions. So these are the areas where, may I get 2 minutes to conclude?
Oh.
So, so in the river management, so this also gives an area. Then in Citizen Zuri platform in Netherlands, it's shown that their ideas were taken by the central government. So the participatory approach gives a kind of a situation where we have seen that successful implementation for the river water management has been already achieved. Now, here I would like to just show you that, you know, when we talk about the decentralization and successful participation, we see that there are few conditions, initiating conditions or context. Now, conditions were given by Blomqvist and Diener and his group, particularly from the World Bank. They studied 83 river basin systems across the world, from across all continents, and they have studied, given this framework, they have studied.
We're short of time, so please try to conclude. Okay.
Yes, sir. I'm on the verge of my conclusion. So coming to this framework, Diener and all, they have shown that there is a context for a successful participation. So when we come to this scenario, we see that, you know, participation gives us a coax from a conflict to a cooperative system, from a complete conflicting situation to a completely cooperative system, where four critical factors I would just like to mention before I stop my presentation. One is the water availability, rather water scarcity. Second is the availability of the information, the level of participation. I mean, it will be at individual level, and of course the political economy, the entire river basin. So with this, I would like to say that the participatory approach gives us immense theoretical framework and also an analytical framework and also an operational framework for understanding the challenges in the management of the river basin water resources. With this, I express my sincere thanks to all the listeners over here, and also I express my sincere thanks to the organizers of the webinar, Foundation of Practitioner Geographers.
Thank you, Paramita.
Thank you, sir.
Thank you very much. So let us move on to Tarun Kumar Mandal. Okay. Dr. Tarun Mandal, I think you are here.
Stop share.
Yes, Tarun, you just replace Paramita.
Yeah.
The
Dr. Tarun
PPT is shared by Paramita. That should be stopped. Okay. Okay. Thank you, Tarun, for joining with us. Please start, and it will be highly appreciated if you can finish within 15 minutes. Okay. Thank you. You can start. Dr. Mandal, you can start.
Tarun Kumar Mandal, Dr. Tarun Kumar Mandal, please.
Please unmute yourself from your end.
Okay, now you. Dr. Tarun Kumar Mandal is an assistant professor in the Department of Geography, University of Kalyani. He will deliver his lecture on the Brahmaputra River, geopolitics and beyond. Sir, you are requested to
Good
start
morning,
your
everybody.
presentation.
Honorable Chairperson, Professor Ellen Satpathy, University of Calcutta, and session co-coordinator, Dr. Ruxana, Alia University, and all the distinguished participants. I am deeply honored and privileged to be invited as a lead speaker to share my views on the Brahmaputra River, geopolitics and beyond in this two-day international webinar on river and changing riverine ecosystem organized by Foundation of Practicing Geographers. On 27 February 2012, the mighty Brahmaputra River, one of the significant transboundary rivers in South Asia, ran dry. In the East Siang district of Arunachal Pradesh in India, people in the town of Pasighat reported that the usually strong river suddenly dwindled to almost nothing. The state's Minister of Water Resources demanded an investigation into whether the shortage had been caused by dam building.
Make it screen. Make it full screen, please. Yes. Yes, it's okay now. Thank you.
And the Brahmaputra River Basin is rich in biodiversity with huge potential for irrigation development, livelihood opportunities, hydropower generation, and navigation. However, the riparian countries face major challenges relating to floods and droughts, infrastructural development, rising suspicion and distrust, and lack of open communication and within and between riparian countries. As a consequence, the river is inseparably linked with regional politics involving the four riparian countries, which are unequal in size and power, and the differences in national interests in the use of river water and power imbalances among the riparian countries, China, India, Bangladesh, and Bhutan, have increased the complexity in South Asian geopolitics. And the Sino-Indian relation is largely depending on the nature of unilateral management of this river water by the upper riparian country, China. The Brahmaputra basin spreads over countries of China, Bhutan, India, and Bangladesh. And the Brahmaputra River flows through China, India, and Bangladesh. And three main tributaries originate in Bhutan. And thus, Bhutan also makes a major contribution to the river. And the Brahmaputra River basin is based within China around 51%, and India around 31%, and Bangladesh 8%, and Bhutan around 8%. And the basin shared by these four countries is rich in biodiversity and has a huge potential for irrigation development and livelihood opportunities and infrastructure related operations such as navigation. And with its massive hydropower potential and water flows the river not only contributes to the economic development of its riparian countries, but also triggers tension and disputes. The Brahmaputra is a unique river basin. The Brahmaputra ranks the fourth largest river in the world regarding discharge at the mouth and second among the rivers transporting the, in terms of the transportation of sediment load. And the basin is dominated by rainfall runoff along with a modest contribution from meltwater from the glacial and snow melt from the areas of the upper basin lying at high altitudes. The Brahmaputra River Basin is one of the major climate change hotspots in the world. The average annual precipitation of the Brahmaputra Basin is around 1100 millimeter, and it receives over 70% of this rainfall during monsoon season, that is June to October. There was a slight increase in annual and seasonal rainfall between 1961 and 2005, although it was not significant. But the basin has experienced an increasing trend in temperature. The warming was highest in winter by 0.5 degree Celsius, and the lowest in pre-monsoon season, and plus 0.3 degree Celsius during the period of 1951 to 1980 and 1981 and 2007. And people living in the lower Brahmaputra river basin that encompasses India and Bangladesh are at a high risk to various types of water and climate induced disasters like floods, riverbank erosion, degradation of land due to excessive sand and silt deposition, and unpredictability and changing nature of these disasters. The impact of the earthquakes on the hydrologic regime of this region is significant, and they have triggered landslides on hill slopes that have resulted at times in obstructions of river courses, leading to the formation of naturally dammed lakes, and which, when collapsed, have triggered catastrophic flash floods. And the effect of tectonic activity on the hydrologic and geomorphic regime of the Brahmaputra river system has been significant. This includes the numerous tributaries and water bodies, that is wetlands, that are scattered throughout the floodplains. The Brahmaputra Basin in Northeast India is in Zone 5, the most active seismic zone in the world. And it constitutes thus an extremely unstable seismic zone that is highly vulnerable for earthquake. And this region has considerable diversity in terms of flora and fauna and endemic species. Indo-Burma, which are 2 of 34 such hotspots of mega biodiversity on the planet and recognized by the International Union for Conservation of Nature. And the Brahmaputra River Basin constitutes a populace of 130 million, where in more than 40% people are living below poverty line, and more than 200 indigenous communities with multi-ethnic communities live in this basin. Thus, the basin is unique, considering its size, annual discharge, sediment load, hydropower capacity, endemic biodiversity, and wildlife. Although it is riddled with physical and cross-boundary governance challenges, and there are many signs of ongoing cooperation, flood session data sharing between India and China, and cooperation on navigation between India and Bangladesh, and cooperation in terms of hydropower between India and Bhutan. Being an upstream area, China has a clear advantage in building dams and other infrastructure to store or divert the flow of the river system. And there is the potential to significantly change the flow rate during times of standoff between the countries. And there are now multiple operational dams in China in Brahmaputra Basin, and more dams are either under construction or planned. China completed the Jiangmu Dam built on the upper reaches of the Brahmaputra in 2010. And 3 more dams at Dagu and Chiacha and Jeksu are at present under construction. China is now planning to construct a giant hydroelectric dam near the Great Bend of Brahmaputra. And the new dam would help generate up to 60 gigawatts of power. That is 3 times that of central China's Three Gorges Dam, and which has the largest installed hydropower capacity in the world. And the proposed structure will be laid over the Brahmaputra River just before the river leaves the Himalayas and enters India at a height of 4,900 feet across the world's deepest and longest canyon. And it is located close to the Indo-Tibet border in Arunachal Pradesh, and the close proximity of the location to India's border means any sudden release of water from the dam would quickly reach India with very little time for evacuation, and this has caused serious concern in downstream countries, that is India and Bangladesh. China and for building hydro projects on the Brahmaputra River in China, and from the perspectives of China, China is home to almost 20% of the world population, but only about 7% of water resources. And the country faces water scarcity, and its water needs are further traced by pollution. And according to the Chinese officials, the hydroelectric project in the Medoc country is a part of that is the giant hydropower, the proposed hydropower project. Medoc County is part of the country's renewable energy generation initiatives, and that it will help China achieve carbon neutrality by 2060, and also pave way for development in the Tibet autonomous region. And the new dam could provide 60 gigawatt of clean, renewable, and zero carbon electricity annually. And the power generated would help Beijing meet its clean energy goals and strengthen water security. And according to Yang Jian, chairman of the Power Construction Corporation of India, and all the upstream development initiatives by China will be based on scientific and from the scholars of China, and they express that all the upstream development activities by China will be based on scientific planning and study, and will take into consideration of both upstream and downstream interests. And in 2004, China's Ministry of Foreign Affairs spokesperson stated that the Chinese side is always responsible in developing and utilizing transborder rivers, and will lay equal emphasis on development and protection, and take into full consideration the influence on downstream areas. China's dams being planned will not affect flood prevention and ecology of downstream areas. But, and from the Indian concerns, in the near future, China is unlikely to pursue plans to divert the Brahmaputra to relieve domestic water shortage, which is a concern for Indian observers, given cost and logistic concerns. And looking at India's main domestic considerations, the focus primarily is on the management of and access to Brahmaputra waters for hydroelectricity, flood control, and local development, and integration of isolated Northeast India into the rest of the country. The diversion of water heavily caused environmental devastation of India's northeastern plains. China has used water as a political weapon against India. The Chinese projects constitute an immense threat to India's water security, and the management of water through river projects was not water shortage, but deadly flash floods and nutrient-rich sediments that enrich the soil of this region would be held back in the reservoir instead of reaching the river's delta. And people of Northeast were depending on its water for agriculture. Now, by this project, Indian farming became vulnerable, along with frequent environmental hazards. And reduction in water discharge of Brahmaputra has added to the problems of poverty, migration, violence, and social instability. And if water is stored in the upper stream by China, and there will be less water flowing, causing negative effects on water use for its industrial and agricultural sectors. And in respect of control of allocations of water, means China will exert substantial economic influence upon the rising South Asian power. And India contends that China will probably carry out interceptions during dry seasons and discharges during rainy seasons as means to impose pressure on Indian government. And lack of transparency and lack of water sharing treaties are major concerns for India. The silent water war can become a reality. And China is a country which adopts unilateral approach in the construction of dams without consulting other riparian countries about how a new dam may affect them, and it does not address its neighbors' concerns. And sharing of the transboundary water resources is a huge challenge to the harmonious Sino-Indian relations. More recently, in the aftermath of border clashes between India and China in the Galwan Valley, May 2020.
Tarun, we are short of time. Okay, Tarun, we are short time, so you please try to conclude.
Okay. More recently, the border clashes between India and China in the Galwan Valley, May 2020. China has blocked the flow of the Galwan River, a tributary of the Indus, which originates in Chinese-controlled Aksai China area, thus altering the natural course of the river to prevent it from entering India. And China, and from 1955, China began to provide the discharge data from 3 gauges on the mainstream of the Brahmaputra River and during the rainy season. And from 1957, China provided hydrological information of the river Brahmaputra to India. And China stopped providing hydrological information to India from 1963 to 2001 after the border conflicts between China and India in 1915 to 1962. And expert level mechanism and memorandum of understanding on provision of hydrological information of the Brahmaputra River in flood season by China to India. And these are the major cooperation processes. But in 2007, this undermined India's flood early warning system during the critical monsoon season in 2007. The India's Assam state, which suffered record flooding dispute below normal monsoon rainfall, and the data denial was apparently intended to punish India for boycotting China's belt and road summits and for the border standoff on the remote Himalayan plateau of Doklam. And the Brahmaputra is an significant transboundary river in South Asia, and its water resources are especially important to its four riparian countries, and three of which are the most populous in the world. And from an Indian perspective, it is extremely difficult to predict India-China hydro relations, and not only because of the uncertainty over the impacts of environmental change on rivers flowing from the Chinese territory to India, but also due to the governance system of China that functions wide and large in a complete secrecy. And a multilateral mechanism for regional cooperation and involving all the riparian states will be more fruitful to reduce the conflicts of the river water of the sharing of this river water. And thank you.
Thank you, Tarun. Now let us invite Dr. Ajit Majumdar. Ajit, please. Time is yours.
Just let me share my screen.
Sir, with your kind permission, I request Dr. Rukhsana Madam to introduce Dr. Majumdar with few words.
Okay. Dr. Arjit.
Just if Torunda stop sharing, I will be sharing my screen.
Dr. Arjit Majumdar is an assistant professor, Department of Geography,
please.
Jadavpur University, and he will.
Sir, you can now share. Or yes, sir, now you can share.
Okay.
Hello.
Yes, madam, you continue your introducing Dr.
Majumdar. Okay. Dr. Arjit Majumdar, thank you. And he will deliver his lecture on an inquiry into the geometrical irony of Ajay River. He is the assistant professor in the Department of Geography, the Jadavpur University, and we are delightful because he is our colleague also, that he had given the service in our university. So I am happy. You are requested within the 20 minutes, you will present your presentations. Thank you for sharing your valuable research.
Thank you, ma'am. Thank you.
Thank you.
Very good morning to Chairperson, LNS sir, Coordinator, Dr. Rukhsana Madam, and she has been my colleague in Ali University. I could see, I could just saw that SKG sir was there, Shubhamita Madam was there. So very good afternoon to each and everybody, and obviously to my very dear friend, Dr. Ajinul Islam, who is the convener of this 2 days seminar, and has given me a chance to share my ideas and thoughts. First of all, let me say that I am specifically not a man of riverine environment. I mean, I'm not working in the rivers, but mostly I'm working in groundwater, just learning. But still, being a student of geography, it's obviously, it's always very likely to explore the things. And since I've been given a chance of this, and therefore, I'll just be sharing my experiences and thoughts that I have worked out during doing the dissertations in the field, and what are my experiences and what are my observations. But I must say that the work is not yet fully completed, so I cannot draw conclusions for this particular presentation that I'm going to share. So the topic was like this, that an inquiry into the geometrical irony of Ojoi River, India. So just introducing my slides. A river system is as we can see this particular photograph or the plate. The water is being accumulated in the river. It may be through runoff, it may be through the ice melt water, it may be from the streams, it may be from recharge from the groundwater being in an effluent stream, etc., etc. And what happens? The tributaries and the meet, and afterwards the river flows to a particular base level. It may be a base level to the sea, it may be to a lake. And therefore, in the process, what happens? The discharge increases, the width increases, etc. And we have all gone through the division cycle of erosion and etc. All the riverine, stages. And therefore, we are all very well acquainted with the fact. Even a layman is very well acquainted with this fact. And to give some light on this, our river basin is actually hydrologically, it's an open system. I mean, this should be said, since we know that the global hydrological cycle is a very closed system, where the energy enters, but the matter doesn't escape from the system itself or does not enter into the system itself. But in case of a river basin, both the matter and energy, both have an input and output from the system. Both have an input and output from the system. So this makes the things much more complicated. In fact, much more complicated. But let us see to my topic. So generally, what we see, this is a very good diagram I've collected in from obviously from the internet, which shows that the degradation and the aggradation in a riverine system tends to be equal, so that there is a gradation along the channel, so that there is an equilibrium that's being established throughout the channel if we take the system as a whole. And again, the curve showing on the right hand side, it shows the x-axis shows the discharge and the y-axis shows the stage. So the stage is actually the height of the water from the bed of the river. And discharge, so naturally as the stage increases, the discharge increases. So this is a very normal phenomena that occurs throughout the world. Now, this is my statement of problem. Now, this is the Bhagirathi River or the Ganges as known in India. In West Bengal, on its western part, there are a few rivers which are flowing from the western, the Chotnagpur Plateau to the Bhagirathi. On the northern side, it's the Ajay River. Then is the Damodar. Damodar used to have a different kind of channel, different course beforehand. Then is the Shilaboti, Rupnarayan, Kongshaboti, and lots of river flowing over there and meeting the Bhagirathi. So these are the tributaries. But its tributaries, mainly I'm taking this Ajay River over here, but a few of the tributaries have been having a very different kind of pattern from that should actually be normalized over here. So what is the pattern? The pattern is that as we move, as say, for example, I'm taking Ajay River over here, as we move downstream, the expectation is that the width of the river will be increasing. That is a normal phenomenon. That's because the stage increases, the discharge increases, the width will be increasing. That's the normal phenomenon. But the observation that I'm observing right now over here, and obviously I have gone to the field for measurement purposes, it has been seen that the width has been decreasing. The width has been decreasing. So this is the geometrical irony, and I'll be treating with this geometrical irony. And if I go by the selection of the study area, obviously I have selected Ajay. The few of the reasons are that it is absolutely a rain-fed river, so there is no snow melting. There is no tidal inputs within Ajay. And if we go by the Bengali literature, say for example, long back, we used to say Ajay North, Damodar North, Rupnarayan North. So today in the course of time, the things have changed. The courses of the river has changed also. But it's fact that the Bengali literature is very rich, and it actually signifies that rivers without distributaries, without having huge distributaries, are defined as north. Other than that, are defined as nodi. So as far as my knowledge is concerned. So taking Ajay River, is a area where I have just systematized the thing without any coastal inputs, water from the coastal inputs, without much more distributaries. Though there are a few distributaries I know, not very big, but there are distributaries. So this is more or less just a location map, just to give the idea if it's not known to somebody. This is India, and it runs from right from Bihar, in the Chotnagpur Plateau from Jharkhand, and enters into West Bengal. And this is more or less the basin. But I'll be focusing much more within the Bengal area. So if I just subset the area, and work on the Bengal area, I'll be focusing on the Bengal area as because since my aim of the presentation is to deal with the geometrical irony, and the geometrical irony is actually occurring in this place where we are expecting the width of the river to be enlarging, but we are getting the different issue on that. I mean, the width is just reducing. So I'll be dealing with the Bengal part. So this is the map which I have got from Texas University archive. This is actually the topo sheet. It is having a scale of 1:250,000. So I've just demarcated Ajoy over there because this is the oldest map that I have been able to procure. Procure from the internet or anything. So this was the oldest map, but it's very difficult to make any kind of measurements because it's 1:250,000. It's a huge. The scale is not fit for measurements. Doing the width of the river, not fit for measuring the width. Now, this is the Ajoy River again being digitized in the 1970 topo sheet that we are normally having. So we can easily see from here that now it's a 50,000 scale map. So obviously we can see that the width is generally it's going down. It's deteriorating. In fact, the width is deteriorating. So let me take a photograph from 2014. So this is the FCC. Basically, this is the FCC. The only observation I would like to have over here is that we are having. So this is the river. The blue line is the river. Obviously, the red portion is the vegetation. This is the upland area, and these are the areas with light blue color. These are actually the obviously agricultural fields because these are showing the huge amount of the soil moisture that the fields are having, and maybe the things are being harvested at that particular time, and therefore the soil is being exposed, and we are seeing a huge amount of soil moisture. Now this is the river. This is the river. So that was not my concern. This is the river. I will go to that afterwards. Now I have just taken up the river from there, and similarly in 2014 also we are having almost the same thing. See, we just the river is being getting narrow. Now, so these are the superimposition of the vectors. There has not been much change. There has not been much change, though the time has also not been very much. 1970 and 2014. That means 30, 40, 44 years. So within 44 years, we may not be expecting, and Ajoy is also being banked by embankment. So the expectation of changes are being less. So now comes the theory. So after observing all these things, the width, the depth, and the velocity. Now, these three things are going to maintain an equilibrium, in a riverine system, in a river, in fact. Everything maintains an equilibrium, every object. Now, if I take up this bottle of water and I place it like this, it will be having if I keep it like this, it will fall. That's because I'm disturbing the equilibrium. So naturally, we have to build up the equilibrium are being built up. So according to Leopold and Maddox, they have given the equations like a W is equal to A Q to the power B, D is equal to C Q to the power F, and is equal to K Q to the power M. So this W stands for width, D stands for depth, and V stands for velocity. And all these are functions of discharge, that is Q. And this B, F, and M are the power values, and A, C, and K are the coefficients. And we can integrate it, and we can just make some mathematical calculations. Obviously, I'm not going to give the mathematical calculations over here, but they are pretty easy. And after getting that to define the equilibrium, we'll be getting this kind of constants. Like A into C into K will be equal to 1, and B plus F plus N again will be equal to 1. That means if I sum up the powers, they will give me a value that will be equal to a numerical 1. And if I multiply the coefficients, again, those will be giving me a value which will be equal to numerical 1. So if any one of these is discharged, say the width increases, the depth decreases, or the velocity increases, maybe the depth decreases, etc., etc. So this is how the equilibrium goes on. Now, as I already said, I have just been collecting the data from the dissertations works, and I've been just in a stage of learning this works based on river. So I've just calculated this data in the field. I've taken the width, the depth, I've collected the discharge data because the water was very less while we were serving. And just after that, if we just look at these equations, to make it very easy, just if we look at the power values, it is seen. In case of width, the power value is 0.032. In case of depth, it's 0.157. And in case of velocity, it's 0.811. So that refers to the fact, given a proper amount of the discharge just in the monsoon season that happens in Ajoy, that the velocity is one of the very most responsible the parameter that is going to align things. But the width and the depth ratio are very big. Width and the depth ratio are very big. Now, if I have to make analysis of the width and the depth, well, I have made some survey on field and I have taken the cross sections. But over here, I have taken the whole 126 kilometer length of Ajay. My students have done this. They have taken the cross sections along the Ajay River at a break off at an interval of 5 meters. And this is how it is being represented. So it is very well understood that the width decreases. The width decreases. So these are the analysis we have done. So this is the cross section, how it has over the distance. We can see that it has decreased. So the river has become actually narrower. This is just something that I've just done yesterday because I wanted to get the just recent image. So again, it is showing the same phenomena. It's so sometimes the width is in the upper basin over here. It's 1.31 kilometer, and in the lower edges, it's only 0.14 kilometer. So next, so if that was the study of the width, then if we go for the depth analysis. So this is a simple profile analysis. This is a simple profile analysis done from the Google Earth. It starts from over here and ends at Katwa. That is from the, not from the source, but from the point entering the Ajay entering West Bengal and at the mouth. So this is how the profile actually looks like. So it's very normal. It's very normal. It's expected to be in an equilibrium, except in some cases because there are some sand mining kind of things going on. So we can be if I have a point over here, so it reflects like this. Otherwise, it's actually normal. It's actually in an equilibrium. So this is the pool refill sequence. So this was done throughout the river, and it's having a very high K value. This K value indicates actually the ratio between the pool length and pool to pool length and the refill to refill length. So it again it emphasizes the equilibrium of the river. So so this was the long profile survey. This is my student Himadri, and we are doing the survey. So we are done the long profile survey through these points. So these are the GPS points collected. So from that GPS point, I have just tried to get the data in the profile that was being defined by Hack. And so this was the profile. We made an SL index out of that. The value is 0.8. So again, it establishes that it's good. Some of the things over here are disturbed. That is again due to sand mining, anthropogenic activities. Otherwise, it's okay. So now what is the problem? Now what is the problem? How it's happening that it's getting narrower? In fact, I also don't know, but I am just having an hypothesis over here. Since I'm a man of groundwater, I have taken this hypothesis only. The change of static water level, that is the groundwater level, in the lower Ajay basin area is creating significant difference in the discharge of lower Ajay river. So this is the hypothesis that I have taken, and I have not proved that, but I've just made some observations. So this is a piezometric surface map with respect to the mean sea level. So it's in the year 1996. It's a pre-monsoon map. So if I just see that these are being differentiated into the level of piezometry, less than 20, 20, 40, 40, 60, and more than 60. So just to have an understanding of it, first of all, I will go to this one. So this is the elevation map. This is the elevation map, and these are the blocks over which I have collected the data through WRIS for the static water level data. The static water level data are basically given as MBGL, that is meters below ground level. So we have to prepare the elevation map. On the basis of the elevation map, the static water level data is being subtracted from the RL to get the piezometric surface with respect to the mean sea level. So if I just look at this map and look at this map, they are more or less equal. Now, if I just have an understanding of this particular area. Now, this is 20 meter, less than 20 meter, 1996. This is 2020, pre-monsoon. This is 2020, post-monsoon. See the area. So the area is increasing. That means the piezometric surface is tending towards the mean sea level. Now, these are the class intervals I have taken. I could have taken it much lesser. So if I consider it to be 20, that the piezometric surface is going down, suddenly going down and approaching the mean sea level, and now the distance is say around 20 meters. And if said just 1 minute more.
Okay.
So if I just take this observation, if I take the profile again, and I don't know whether it can be seen, but it's a 20 meter line. So it's coming over here. So round it. So the water is actually this diagram and the previous diagram. If we equate it, it shows that the water is actually penetrating inside. The Oja River having a huge permeability of the base, it's bound to have the water penetrating inside. That is one of the reasons. But I have the limitations of the study because the study has not been conducted over a longer period of time. I mean, I couldn't have extended up to 200 years back or 300 years back because geomorphologically, I wanted to know whether the river has taken the narrower bend in the modern area or it has continued since long. I don't have the data right now. Maybe I'll be conducting my work in future. And secondly, the embankments on both sides of Oja must have an impact on the width of the river. So these are my observations of being a student of geography. I'm learning all these things, and thank you. Thank you.
Thank you, Rijit.
Thank you, sir.
Now, without wasting any time, let us move on to Dr. Balai Das. Dr. Balai Das, are you here? If he's not here, then we can. Is he here?
No, sir, he is not present.
Otherwise, let us.
On the place of the Balai Chandra Das, that Dr. Shubodh Chandra Pal will speak here.
Okay, nice. Fantastic. Shubodh, please.
Dr. Shubodh Chandra Pal.
Sure.
From the Department of Geography, University of Burdwan. He will speak on the climate change impact on the flooding Dwarkeshwar River Basin. Please, sir, you will start your presentation. Thank you for accepting and presenting your presentation.
Thank you, madam. So let me share my screen first.
Devabrata, please enable sir to share his screen.
Yes, sir. You can share.
Okay, sure.
Is it visible?
Yeah, it's visible.
Yes.
Okay. So my today's topic is about. Am I audible? Sir?
Yes.
Okay, thank you. So my today's topic is about climate change impact on flooding in lower Dwarkeshwar River Basin. So here you can see some snaps related to flood hazard index, disaster risk index of states and all. In case of flood hazard index, you can see West Bengal state actually ranked high. And in case of disaster risk index of states, again, West Bengal ranked after Maharashtra. And in case of disaster risk index among the districts, again, you can see there are some districts belongs from West Bengal states actually ranked high. So this was actually reported in the year of 2016. This is the flood situation of Ghatal region and surrounding. So during that time, we had a bit of notions about that there are probably many research articles which are available related to flood susceptibility and vulnerability and so on and so forth. But there are probably very limited research articles which are available regarding climate change and flood. So that was the notion we had in 2016. And in that time, we thought of such kind of a topic to research, and eventually we have completed it. And this is a very popular diagram. I think many of you actually came across this diagram. So from this diagram, we can easily understand what is actually happening in our planet. If we see here, in earlier time, the temperature was very much, high. Later temperature was decreased, and in case of early Eocene period, again temperature was increased, and later again temperature decreased. So this is the warm period, this is the cold period, again temperature gets higher, so it is again warm period and temperature then again decrease. And in case of Pleistocene period, again you can see there are many ups and downs related to the temperature. Okay, so and in case of early Holocene period, again you can see there are many ups and downs, but these are not so much abruptly changes of climate. Temperature I have noticed, but from late Holocene period to up to 2100, as IPCC predicted, that temperature is actually abruptly increased, and it will actually coincide into that particular point of temperature. So if such kind of abrupt changes of temperature we will notice, then we obviously can claim that climate change is actually happening, or global temperature is actually increasing. Even IPCC also just published their 6th assessment report last month on 9th August and in this year, and they claimed that in the year of 2100, temperature will increase about 2 degrees centigrade. So if it will happen, then what will happen in Delhi region or in Himalayan region? In case of Delhi region, we all know that last couple of years before, the recorded temperature was near about 46 or 47 degree temperature or so. If temperature will increase in the year of 2100, then the Delhi temperature will be close to 50 degrees centigrade temperature. And that 50 degrees centigrade temperature is actually huge temperature, as far as IPCC's 6th assessment report is concerned. And here you can see it was actually reported by NASA in the year of 2020. And what they have noticed, it was actually basically depends upon the land and ocean, temperature data. And they have noticed that beyond 1940s or 50s, there is sharp increasing trend of temperature. Though there are many ups and downs, but still there is increasing tendency of temperature we can observe here. And say, for example, there are many research work which are available in internet related to climate change. And if we consider, say, for example, one single trap, which actually represents 10 years data or 20 years climatic data, then in case of that trap, people can say that, yes, temperature is increasing or rainfall is decreasing or so on and so forth. But if we consider many traps, say, for example, if it represents 100 years or many data, more than 100 years data, then we can easily understand that temperature or climate is not changing. It's actually oscillatory in their nature. So from that oscillatory behavior of the climate, we cannot say climate is changing. But if we notice such kind of abrupt changes or behavior of the climate or behavior of the temperature like this, then we can easily claim that climate change is actually happening, like IPCC already claimed. So from here on, I will be only focusing on that particular region, Lower Darkeshwar River Basin. So here we have done what? We first observed daily rainfall data, and also collected Aros Palsar Dam and GCM daily rainfall data. And in case of observed daily rainfall data, we simulate it for rainfall and discharge simulations using rain on grid model. And we also prepared rating curve and peak discharge estimation has been done. And we also done the prediction related to flood frequency analysis for the 2016 and also future scenarios as well, on the basis of Gumbel frequency distribution method, Weibull frequency distribution method, log normal frequency distribution method, and log Pearson frequency distribution method. And in case of GCM daily rainfall data, when we downloaded this data, we actually had to follow the statistical downscaling method to convert the data from global to local one. And also similar kind of, simulation of rainfall discharge using rain on grid model has been done, and extractions of annual peak discharge and all these stuffs has been covered. And one thing I just want to mention, bias correction is important here, because until and unless you are correcting the biasness of your data, it will show something which you are not actually expecting. So bias correction is very much important, which has been done on the basis of or based on the observed daily rainfall data. And also future predictions for all RCPs like 2.6, 4.5, 6.0, and 8.5 has been done. And gauge height determination, flood prone area mapping for 25 years return period, 50 years return period, and 75 years return period also been done. And here you can see this is the gauge height of Arambagh stations, and you can see that extreme danger level is about 17.5 meter, and danger level is about 17 meters. And these are the rainfall stations which we have considered here for this study for simulation and future predictions and all. And here you can see this is the observed and simulated gauge height. And in the year of 2016, this actually crosses the extreme danger level limit about 18.5 or so. And this is the rating curve of Darkeshwar River. Here you can see this is the observed and GCM discharge. This is the bias corrected GCM discharge, this one bias corrected GCM discharge, and this is the raw GCM. So you can easily understand this raw GCM is far away from the bias corrected GCM discharge or observed discharge. So until and unless you are correcting your bias, it will predict something beyond your expectations. So that is why bias correction is actually important. And from this bias corrected data, you can obviously go for prediction and all these things. And this bias correction actually is showing very much close to, observed discharge for all return periods. From 10 years to so on. And this is the estimated annual peak discharge of Arambagh stations. Here you can see in case of log Pearson type 3, it is showing much higher than the other method. Probably it is more than 2,500 cubic or so. In case of other method, you can see it is close to 2,000 cubic or 2,100 cubic or so. So close to 2,000 cubic or more than that for return period of 100 years is very much huge for that particular region, because if you see lower Darkeshwar River, it's gets narrowed down. So 2,000 cubic is much more annual peak discharge for that particular region. And this is the predicted flood affected areas which has been done on based on the Weibull method, Gumbel method, log normal method, and log Pearson method type 3. If you see that log Pearson type 3, the hazard map of log Pearson type 3, then this is much lesser than the Gumbel method, but predicted. And in case of log normal method, you can again see the flood zonation is much to some extent lesser than the Weibull method. So these are the I mean, flood hazard map of 2016 for that particular region, and which we have validated also using popular, I mean, method like receiver operating characteristics curve, and you can see the table value also regarding this. And this is the frequency distributions of annual peak discharge of Riverbank station, where you can see one thing that in case of RCP 8.5, the annual peak discharge is about, I mean, more than 1800. More than 1800. You just forget about RCP 8.5. If you see RCP 4.5 and 6.0, in case of that, again, you can see the annual peak discharge is about close to 1,800 or so. In case of return period, 50 years or more than that. So 50 years return, for 50 years return period, that annual peak discharge is too much higher for that particular region. And here, this is the frequency distributions of annual peak discharge again, where we have compared it with the models, and we have find out that in case of log Pearson type 3, it is actually showing much higher. But in case of, I mean, Weibull or Gumbel method, you can see it is much closer to the RCP 4.5 and RCP 6.0. It is about 1,800, close to 1,800 or so. So for, I mean, all return periods like 30 years and 40 years and so on. And this is the frequency distributions of river gauge height. And here you can see in case of log Pearson type 3, it is much higher, beyond, I think, 20 meters or so. But in case of, I mean, Weibull and Gumbel frequency distribution method, it is close to, I mean, 19 meters or so. And it is again very much close to the RCP 4.5 and 6.0. So, and I have already mentioned that in case of Riverbank station, extreme danger level limit is about 17.5 and danger level was 17 meter. But here methods or RCPs are showing that the gauge height will be near about or close to 19 meter in case of the return periods of 20 years or 40 years or so on. So that is, this gauge height is actually what is predicting from our outcome is much higher. And finally, we have prepared this flood-prone area mapping following Gumbel, Weibull, log normal and log Pearson type 3 method. And we have also prepared the flood hazard map for all these scenarios like 2.6, 4.5, 6.0 and 8.5. Here in case of, I mean, RCP 4.5, you can see in if we consider 25 years return period, then the inundated region is that. And in case of 50 years return period, that, I mean, inundated region gets doubled or more than that. And if we consider 75 years return period, then that inundated region gets, I mean, more than 50% of so or so. Sorry, madam.
Conclude.
Yes, just concluding.
Okay.
And in case of RCP 6.0, you can see in 25 years return period, the inundated region is much higher than compared with, I mean, RCP 4.5. And in case of 50 years return period, again, we can see a little bit higher than this region. And 75 years, more than 50% area of this study area will get inundated. So keeping all these things into mind, I can say that these are very much vulnerable. This area is very much vulnerable in terms of flood hazard. Though there are many, master plans has been taken care of, but still it's actually required much attention to pay for. Thank you, madam.
Thank you,
madam.
Subodh. So let us proceed to the next presenter.
Thank you, sir.
Subhendu Roy. Thank you. Subhendu,
I think
here?
Subhendu Roy.
Subhendu.
Sir, it will be Indira Samantha.
Indira. Yes. So, Indira, please.
Yes, sir. I am here.
Okay, you continue with your presentation.
Am I audible, sir?
Yes, yes.
Am I audible?
You are audible? Yes, you are audible.
Yes.
So first I have to share.
Conclude within 15 minutes. Okay.
The previous participant, please stop sharing your screen. You are still sharing your screen.
Now you can share.
Yes.
Dr. Indra Samajdar Gangopadhyay. She is an associate professor in the PG department. In the PG Department of Geography, Barakpur, Rastagra, Surendra College. And she will enlighten to us to speak on wetland are vulnerable resources, a case study of Nadia district. Ma'am, you are requested to start your presentations.
Ma'am, please close these windows or minimize it. Now you can find it.
Yes, okay. Many windows are open, I think.
Ma'am, please minimize it.
Is it visible now?
No, ma'am, you minimize your Zoom window.
No. Is it visible now?
It's visible, but you have to minimize your Zoom window. Yes, click on the minus button.
No, I have just minimized my Zoom window. Is it not visible?
No.
Ma'am, please stop share and after that again share your screen.
Again,
that will be better.
Okay. Is it visible now?
Yes. Yes. Make it full screen.
Thank you. Good afternoon, everybody. Respectable Professor, Chairperson, Dr. Professor Ellen Shotpoti and Dr. Ruxana and all distinguished guests. My topic is wetlands are vulnerable and my study area is Nadia district, West Bengal. So we know that the most accepted definition of wetland has been given by Ramsar Convention. And the wetlands are immense values, have immense values to safeguard our environment from both socio-economic point of view, and they are the most productive ecosystems. But in spite of the fact, they are also most threatened ecosystems at present. My paper is concerned with the resource utilization and degradation of the vanishing wetland resources of Nadia district, West Bengal, and their conservation and management of this fragile ecosystem. The main objectives of study is to study the resources of these wetlands and their proper utilization, to analyze the causes of degradation and also the effects of degradation on the biodiversity, and to review the utilization and management pattern of these wetlands. And modern methodology are used for my study. And the significance is that Nadia district is a part of matured Ganga Delta. It is situated in the lower Ganga Delta region, and it is the land of rivers. Several rivers like Bhagirathi, Jolongi, Churni, Mathabhanga, Ichamoti, and River Bhairab are constantly shifting their courses in this part, and the shifting courses along with the meandering courses has created innumerable freshwater wetland resources like oxbow lakes, abundant river channels, cut-off meanders. They are locally known as beels and khans. And along with this, the seasonal waterlogged areas, the agricultural lands, all of these are there to create a huge amount of resources, wetland resources in this part of the district. But due to population pressure, due to biotic pressure, due to human interference, the wetlands in this district are degraded and destructed, and they are the most vulnerable resources. So my study area is mainly the northern part of Nadia and a very small part in the south, that is a part of Uringata block. And according geologically, this is a floodplain region formed of recent alluvium of river Bhagirathi Hubli, and there are three geomorphic units: Bhagirathi surface, Katua surface, and Betua Dowri surface. And a variety of landforms has been also recognized on these surfaces: abundant channels, cut-off lakes, oxbow lakes, and meander loops, which are mainly prominent on the Katua and the Bhagirathi surface. The Bhagirathi surface is the youngest geomorphic unit, and also a large number of natural levees. They are present, and these are converted into wetlands. And so this is the relief map of this region, and the northern part is highest, and here the height varies within 30 to 70 meters, and the middle part, here the height is within 30 meters, and this part, the southern part, it is the area of lowest elevation. And you see all the rivers and a large number of wetlands are also noticed in this map. And so this is the drainage map of the region. It is the land of rivers, river Bhagirathi, Jolongi, this is Churni, Ichamoti, all these rivers, and these are the wetlands which are created due to the shifting nature of these rivers all over the region. So the wetland morphology, the wetlands are, some of them are seasonal and some of them are perennial. So you see this wetland, it is Damodar Bill, it is situated in Krishnaganj block, and it is totally a semi-derelict wetland that is during the dry season. Again, during the rainy season, it becomes filled up with water and it also floods its bank. And this Hashadanga Bill, it is situated in Krishnanagar 2 block. Then Uttompur Khal, it is an abundant river channel. It is a typical oxbow lake. These are all the seasonal wetlands. Chakna Bill is also a perennial wetland. Bhomra Bill is perennial, but it is very much weed choked. Kulia Bill, Bhomra Bill, Kulia Bill, these are situated in the southern part of Nadia. So accordingly, the wetland morphology has been divided. So the ownership pattern, the majority of the portions of the wetlands are vested. That is, their nationalized water body owned by the Fishery Department of the Government of West Bengal, and fishing right is given to different cooperative societies. And if some of the wetlands are also privately owned water bodies, and the fishermen, they take lease from Land and Revenue Department, Government of West Bengal. So the wetlands are used for various purposes, mainly for fishing, then our domestic work, navigation, and also jute trading. Jute trading is also an important activity which is practiced in these wetlands. And for navigation purpose, also some of the wetlands are used. There are large biodiversity in these wetlands, a variety of flora and fauna, variety of fish species, different types of hydrophytes, They are found in these wetlands. And another important thing, a large number of bird species. They are both residential and migratory birds. They are found in these wetlands. But despite of this important role in maintaining the ecology and economy of this region, the wetlands are highly endangered and they are affected by various problems. The foremost problem is siltation. Here, this is highly silted bill. It is dredging work is conducted in this bill. Then it is encroached by agricultural field. They are affected by pollution from the sewage of the different settlement areas, and also the pesticide and insecticides of the agricultural field, nearby agricultural fields, and also by domestic sewage and sludge. Jute rating is also causing pollution in these wetlands. So the effect of pollution is very profound on the biodiversity. These land use and land utilization maps has been prepared formerly, and in 1990 and 2002, there it is seen that here in 1990, the map, the number of water bodies or the wetlands, the number is much more. But you see in 2002, the number has been decreased much, and the agricultural land has been increased. The built-up area has also been increased. And here also it is seen that the built-up area has been increased. There is deterioration or degradation of the water bodies. The vegetation area has been decreasing. It is decreasing profoundly, and the agricultural land has been increasing. This map has been, the land use land cover map has been prepared from on 2010. And here it is seen that the built-up areas is still increasing. The vegetation is much less than the former, and the agricultural land has been increased much. And in 2020, the vegetation becomes very little, the vegetation area. The settlement and the built-up area, that is roads and settlement, it is increased, particularly in the southern and central portion and also in the northern portion. And as a result, the wetlands has been very much degraded and they are almost vanishing. The effective water use area has been almost lost. And so this is the temporal change, and here it is seen that the water body is decreasing area, the built-up area has been increasing, the vegetation has been decreasing largely, and the agricultural land has increased much. And so this is some pictures which show the environmental degradation of these wetlands. The jute fields are engulfing the wetlands. The agricultural lands are encroaching. And the macrophyte and weed infestation is a very common problem due to the organic load. And the eutrophication, algal bloom, these are common problems. And as a result, the effective water area is almost not present there. That is, the wetlands become totally not suitable for use, human use. And these bills are derelict or semi-derelict. And Onjona, this is a picture of Onjona bill. It is very much affected by the municipal effluent. It is situated in Krishnanagar 1 block. So the conservation wetland resource management implies sustainable use of the resources for maximization and long-term benefit of the society and minimization of the waste products. So holistic approach for the development of these floodplain wetlands are very much needed, and regularly and timely arrangement of finance for the rejuvenation of these wetlands, limitation of fish mortality, because the stakeholders are dependent on these wetlands, the local people. So if the fishing activity has been disturbed, the fish mortality is a common cause due to this pollution of these wetlands. So their social and economic development has been affected very much. And so steps to strengthen the extension services. Development of eco-aquaculture is a suggested measure which not only enhance productivity and maintain the health of the wetlands, but it also helps to enhance the income of the farmers. So these are the management practices. Due to siltation, several management practices has been started by government, NCDC, and jute rating. Due to jute rating, there is decline of water quality. So application of lime has been suggested. or the jute rating can be done at a rate of 1:30. That is 1 part jute rating into 30 part water. And decline in water quality due to sewage pollution. And the organic load are very huge amount of organic load is the wetlands are suffering from. So as a result, the DO, that is the oxygen, the dissolved oxygen is very much deteriorating, and the BOD has been increasing, which affect not only the fish but also other aquatic organisms. And this is due to the infiltration of domestic sewage and also the agricultural sewage. So the algal control and integrated pest management has been taken by the Department of Agriculture through rice and fish cultivation. This is one of the practice for integrated pest management. Pest management practices has also been taken up for removal of the aquatic weeds through different physical, mechanical, and chemical processes. Deployment of organisms like snail and other insects, they can also check the growth of these aquatic weeds. So control of aquatic insects, then aeration, addition of oxygen. There is some amount of dissolved oxygen, but due to organic load, the amount of dissolved oxygen has been decreasing. So aeration is needed. Conservation of wetland plants for sustainable development. A large number of wetland plants like matchsticks, ogla, then a large number of medicinal plants, kulekhara, olmi, then shushni. These are the medicinal plants which are found along the catchment areas of the wetlands. So the embankments and the edges of the bills can be reclaimed more by cultivation of these wetland plants. And ecosystem-oriented fishery management is very much necessary, and it is taken up by the government. For example, environmental monitoring, so that the dissolved oxygen level should be close to 5 parts per million. The pH should not be more than 7. The biological oxygen demand should be restricted to 3 parts per million. And different fish husbandry practices like pen culture for stocking and nursery stocking, for cage culture, for air, that is taken up for air breathing fish culture, and many fishery options like capture fishery and culture-based fishery. Many of the wetlands are open. Open means they are connected with the rivers. And so there the capture fishery is practiced, and in the closed wetlands, that is they have no connection with rivers, or due to pollution or due to weed choking, they become closed. So these in these wetlands, the culture-based fishery can be practiced, because these wetlands are affected by human intervention. So if the culture-based fishery can be practiced, then the wetlands can be developed. So these are the pictures of different activities, that is nursery and pen culture, cage culture, hatchery, and other culture and capture system, which are practiced. So my findings and conclusion is that this feverish tempo of developmental activities has severely threatened the wetlands. There is large number of wetland resources in this district, but now they are almost vanished. And the fishery departments and the cooperative societies are also, most of them are defunct. They are not maintaining the health of these wetlands, except in some of the blocks. And the direct human intervention due to agriculture, as due to pressure of population, the agriculture has been increasing day by day. And pesticide and sewage discharge is a common cause, polluting the wetlands and affecting the biodiversity. And the ecosystem has been disrupted. The trophic level has been affected. The food chain and food web has also been affected. So this upsets the ecological balance and decrease the values of the wetlands. So lack of community involvement is observed by me. And so the conservation and development program should be taken up for the proper management of these wetlands. Absence of policy and regulatory mechanism from the government level and also from the non-government organization. So it should be looked after. And emphasis is not given on integrated approach because socially, economically, and ecologically, these water resources are very much important. So more that is participation of the stakeholders is necessary. Absence of baseline data for further research work and ineffectiveness of implementing agencies at different levels, and lack of appropriate strategies for implementation of the developmental program is also observed. So wetlands play vital functions in maintaining environmental sustainability. So the resuscitation of these water bodies, of these valued resources should necessary, and it is undertaken in perspective of an attempt for the conservation and development of these wetlands. Thank you.
Thank you. Thank you very much, ma'am, for the wonderful and excellent and detailed presentations. Now I have requested to our chairperson, Professor Ellen Satpathy, to conclude or comment on all the excellent presenters' presentations. Sir, you are requested and end of the sessions after your comment.
Okay. Thank you, Ruksana. We have this session, a fruitful session ranging from the invited speakers, then the lead speakers, and also some of the presenters. And from various local experiences, they have shared both from their field experiences as well as some of the modeled experiences. But you know, in any geographical inquiry, we have to look into both the larger perspective and the smaller perspective, with reference to the time window as well as the spatial window. And again, there are so many factors in any kind of outcomes, and they have their different dimensions in these two windows of time and space. And the relationships are not always linear. There are many that there are non-linearities there, curvilinearities there, and how they are operating, that is very important, but we have to select whether it should be in the Anthropocene and later part of the Anthropocene, and also for the futuristic. Sometimes in some of the papers, downscaling of the various internationally recognized models, like say representative concentration pathways, how to do that, and whether in any kind of hindcast, they are definitely at the global scale, they are operating as a regional scale, they are also operating. There can be some good fits are there, but whether they can fit at a very local level, and on the basis of that, the future predictions can also be done. We have to look into all these issues. I can give the examples of some of the river basin areas. Somewhere the tectonic activities, rather paleotectonic activities, those which are still operating, they have very good influence. But in some certain other environment, only the diurnal factors, like say in the coastal areas, the diurnal factors, the range of the diurnal environments and the ecosystems, they are also playing significant roles. Some of the episodic events also, they have their roles. What was in the keynote address by Professor Sonat Busaid, he has very rightly pointed out the philosophical issues also in our interpretation of the landscapes. And the rivers are not any exception to this. Since our concern, particularly in the Indian and subcontinent and the global south also, here majorly we are living in the humid tropics, where rivers, it's water, it's land associated and all that, so they are very significant. And our cultural landscape is also very much associated with this. And definitely how much intervention to the rivers as the active agent, human becomes as the most active agent right now in the Anthropocene. But how long this will continue, and whether the RCP, the higher or the lower that will operate, or maybe the mid path, we don't have any right kind of estimation at the local level or a very sub-regional level. So we have to single out in every scientific research, all the factors are operating at the same time, but at the different scales. So we have to single out which one is more important at a certain particular scale, and then what kind of adaptive strategies can be taken up, mitigation strategies can be taken up, the monitoring systems can be developed. So overall, all the papers are very nice, definitely. And I congratulate all the speakers who have presented their presentations. And we have finished within the time. That is the most important thing. Thank you, and it's over to you, Ruksana. Ruksana, can you hear me?
Yes, sir, yes.
Okay, it's over to you.
Dr. Arun Kumar, sir, I
Why?
have requested.
I can't speak anything out on your river dynamics. That is beyond my capability, in fact.
Sir,
but I'm thankful to you, thankful to Professor Satpathy for managing the, what you can say, the whole session nicely, very nicely, and finished it in time.
Thank
so if you and if there was any absentee in this session, sir? What about Balai Chandra Das? Balai Chandra Das was absent.
Balai was absent, and Subhendu was absent, and
Subhendu was absent.
He has some mishap in his house.
Okay. Okay.
So that's why he couldn't join.
Mm-hmm.
And that was the reason for that we could manage within the time.
Right.
So 3 absentees are there, and we gave the time to all the speakers. No problem.
So enough time. I think the chairman and the session coordinator has given enough time to the speakers, and there should not be any grudge or any complaint that in the seminar of Foundation of Practicing Geographers, the presenters don't get time.
And we also invited questions from the participants through the chat box, but no question is there.
Okay,
so there is no nothing to do with the question answer.
Because
so let us conclude this session.
Yes.
With our sincere thanks and regards to all the presenters, especially our esteemed guest speakers and the lead speakers, and nonetheless the others also. Thank you very much.